or in Kotlin, up to you, any JVM language. But interestingly, we're not trying to reinvent the wheel, so we use a standard data model where the states on the ledger, transactions, all the stuff is actually instances of Java classes. And what we're going to be defining today are Java classes that do things, represent things. So we've got our token state, which represents our tokens on the ledger. We'll have a token contract that governs how this token evolves. So you can think of that like in Bitcoin world, you have a set of rules. Input values must equal output values. The owner must sign, etc. These contracts we'll see are very different to Ethereum style contracts. So they're not mini machines that you send instructions to. They're a set of constraints on what the transactions can look like. And then finally we'll write a token issue flow, which allows us to issue tokens onto the ledger. And a flow is just a piece of code that tells that you can start. It's like a function you can tell your node to execute, and it does all kinds of stuff. It doesn't necessarily need to update the ledger. You can just tell your node to empty its database or go and query an API or just do some housekeeping. But in general, when you write a flow, and in the flow we'll be updating the ledger in some way. So if you're familiar with other blockchains, I mean, the only thing you'll necessarily have seen if you're looking at the Ethereum thing is the kind of contract stuff, and even that's very different here. But they kind of map reasonably well to kind of Bitcoin ideas. So that would be the actual Bitcoin input outputs themselves. The contract would be the general rules of Bitcoin, which are hard baked into the platform. And the token issue flow would kind of handle all the stuff you generally in kind of a Bitcoin or Ethereum setup have to do yourself. So stuff you'd write on the client side. In Corda we package that all up into the node, so it can just be, you can kind of file and forget the process of issuing a token or stuff like that. Yeah.
When you say class, you have a host of token states, a host of token contracts, and token flow, because you use the word class there.
So no, so that's a class in Java terms. It's a programming class. Oh. So token state will be a class, and instances of that class will represent tokens on the ledger. Does that make sense? So that's what we're going to be building today. We're going to kind of do it in chunks, do some test-driven development, and by the end of the day, this will be our CorDapp. We could also go further. Obviously, we could have a token transfer flow to make this actually useful, but for the purposes of today, we'll leave it there. So the first thing we need to talk about Corda is this idea of the network and nodes on the network. And Corda networks are these kind of fully connected graphs. So everyone on the network is aware of everyone else on the network using something called the network map. And everyone on the network is permissioned. So if you see here, there's some companies, Colorado River Authority, with a public IP address, it's public key. And the way Corda works is it's a permission network, and when you join that network, you download this signed document called the network map, and you get to know who else is on the network and what their public key is. And there's two reasons we do this. So the first is that it allows you to know who you're transacting with. So if you think of using this for a business use case, it's often a requirement that you strike legal agreements or transfer digital assets to real known counterparties, not just public keys, right? And the other thing is, by using this approach, we don't have to use the kind of blockchain gossip protocol approach. So in Corda, if Bob wants to update the ledger in some way, instead of sending a message to everyone on the network telling everyone what this update was, in Corda they'll just look up Alice on this network, use their public key to create kind of an encrypted TLS channel, and just send this ledger update directly to them. So information is distributed on a need-to-know basis, and for that you need to know who your counterparties are on the network and what their IP addresses are. And finally over here we have this concept of a node tree pool as well, which we'll talk about in a sec, which is a kind of a pluggable way of preventing double spends on the network. Does that make sense?
Yep.
Yeah? So it's basically kind of a big permissioned network, and anyone can speak directly to whoever they want instead of using gossip protocol.
I have a question.
Yeah, sure.
So, which is the certificate authority that you're going to use for TLS messages and all those things? Is it?
So for any network, the person state of the network would end up being the root authority. You could use a traditional root authority if you wanted to. So you could use one of the existing ones out there, Varus or Symantec, whatever. Am I getting that right? But one of the existing certificate authorities, and they issue these certificates. So you also use your own certificate authority. It's up to the network operators to permission people using a KYC process.
I'm coming from the operator side. If I'm the network operator, then basically I have to initiate my own C authority. And is there enough documentation on that? How to
Yes, there's a docs page about what the format of the certs have to look like, etc. So you create, there needs to be some kind of root authority, but it could be an existing one. Then you have intermediate CAs who sign certificates for the nodes through a KYC process.
So what is the process for the nodes to get permission to join the network?
So that really depends on the network. So we're going to stand up our own network, which will be some big CorDapp network, and we'll have our own approach. But if you set up a network, it's really up to you. So these certificates is the kind of standard certificates, the structure's described, and then you need to create your own what's called a doorman, who provisions these certificates to nodes. So it's not prescriptive in that sense. It just needs to be kind of a certificate that follows a certain format for other nodes to trust it, but the person providing the certificates is up to the operator of the network. Yeah, raised a lot of questions. Yeah, Charles.
So quick question. So you said when Bob needs to communicate with Alice and even say a private message, that means the data, the ledgers at Bob and Alice will only be updated. No other ledger maintained by any other node will be updated, right?
Yeah. So in fact, we'll see it in a second again. So each of these nodes is backed by just a standard SQL database. And that's where they store their information. So there's no central repository of information. So what we do guarantee is, Bob and Alice are seeing the same entry perhaps in their SQL database, but Carl doesn't even know about this. This isn't even, it's not like it's stored in encrypted form or anything. Literally, it's just information that's never been sent to Bob, or to Carl, sorry. Yeah.
I have a question in the same regard that he asked, that, if Bob is is it assumed that these nodes trust each other? If Bob wants to cheat and actually removes a row from his database,
Yeah.
How does the network guarantee that he's not able to cheat?
So it's standard crypto stuff. So if Bob and Alice sign an agreement and they both store it, then even if Alice throws it away for some reason, Bob's got Alice's signature linked, on the certificate of Alice to prove that Alice agreed to that thing.
Okay. So basically, it's based on the signing of the thing.
Yeah, so it's like the non-repudiation of having signed something which fixes the contents and means that you can't then go back and say.
So the certificate that they use for signing and the certificate that they use for TLS, is it the same, or how is that managed?
So there's a page on the docs I can bring up very quickly. But basically the way it works is you kind of have a certificate chain even within the node. So if I go to, am I online? I think I'm online. So if I go to, and we won't spend too much time on this, it's not a huge focus for today, but you end up with a structure like this. So you have the root CA, and they permission the intermediate CAs like the doorman. Then the doorman will sign a certificate for the node, and that will kind of be the node's own CA, which it will use for its well-known legal identity that it uses in transactions. Any confidential identity it wants to use, which it can generate child public keys to use on a one-off basis to prevent people linking its identity to stuff. And then also it'll generate a TLS certificate from there.
Oh, so there are two different certificates. There is a signing certificate and the TLS certificate?
Yeah, so each well-known identity will have a public key, and this is registered in the network map.
Okay.
Then you can also, you also issue TLS certificates as well.
But that's for the well-known identity. What about not well-known identity?
So then your well-known entity will issue child public keys, and it will create certificate chains for those child public keys that are confidential.
Okay.
So for each transaction, you choose to be identified by name and public key, or just by public key.
Okay.
Yeah.
So let's say the Bob completely lost his node.
Yeah.
How his node could be recovered?
So in theory, he could request the stakes from the counterparty, but then there's the issue of, well, if they're not willing to give them to Bob, then he's in trouble. But what needs to really happen is just, we're using standard databases, and we expect you to use standard database kind of backup procedures. Because even in the standard blockchain, even if your node goes down and use your data, you can re-request the data, but you can't re-request your private key, you can't re-request all the metadata you're using with these applications. So even in a standard traditional blockchain, even though they don't make it easy, the best approach is just to properly back up your databases.
But is it possible to recover some of the transactions with Alice or Carl?
If they're willing to share them with you, yeah, they can send them to you, but only if they want to, right? You can't force them.
Recover from them.
You could, if you start your private key though. Sorry, Mark.
If I'm seeking to something, can I have multiple nodes so I get multiple results in case I have one fail or something like that? Then say geolocation and say process geolocation. Or do I need to really look at the database and the location of the data?
Yeah, Yeah, so we've got an enterprise release coming at the end of the month, and a big feature of that is high availability disaster recovery. And we're currently releasing hot cold, so you basically have another node that you could start up in the case of failover. And so the message broker is uncoupled, and then messages would start going into the new node instead. But we use kind of Artemis message brokers, etc. So we kind of get a lot of the kind of durable message queues for free. So even if your node goes down, things will just build up in the message buffers and get resent into the receipt. Yes?
On sensors, like in Ethereum, they had proof of work. So here it is more by the notary.
Yes, let's talk about notaries. So that's my next slide. So if I bring this up here, and I can send you these slides afterwards. We didn't put them on the USB, so we're always kind of modifying them. But the way it works in Corda is you have notary pools on the network, and they can use any consensus algorithm they want. So if you had an atmosphere of extreme trust, so if you're very trusted, you're willing to see all the data, then you can run almost like a single node or a pool of mutually trusting nodes. And so that would maybe be a regulator or some kind of central bank who steals information. And they would then perhaps there'd be a pool which would use a very high speed consensus algorithm like Raft. But then if you don't trust the notary to see your transactions, which is generally the case, right, then you use something like this. So the notary won't see the transactions, it'll just see the hashes of the transactions. So it can't recover any information, so it doesn't know what it's signing. And so that's one layer of kind of protection. And on top of that, the nodes in the notary pool will be running a Byzantine fault-tolerant algorithm. But we're not tied to proof of work and stuff like that because there's no risk of civil attacks. It's a permission network. So in practice, we can use much faster kind of cutting-edge consensus algorithms like Avalanche is one we're looking at. We've got an implementation of BFT Smart, which we're replacing at the moment. But we have BFT Smart now. We're not that happy with it. It's an open source library, so we're probably moving towards commercial stuff. I know Avalanche is one thing we're looking at.
So even though the transaction content is hashed, the sender of the transaction is still readable.
Yeah, so the notary, that's the one thing they'll see. They'll see the transaction hash and they'll know who sent them this thing. But then that doesn't even mean necessarily that they're involved in that transaction or that they're the only person involved. So what they see is a hash and the person who's asking them to notarize. Yeah?
So in the network map that you showed, do the IP addresses have to be static?
We generally assume that you can update the network map, but in general you want relatively static IP addresses. I think you can specify a range. I'm not entirely sure. If I pull up the node config docs, I can probably see if let me just go back to the docs. I think we can ranges, but in practice we expect it to be a certain address kind of permanently. Or kind of for them to change slowly at least. So I think for now you're tied to one IP address, but then you could modify the network. You could update the network map if you need to, if you have to change your IP address for some reason. Any other questions about this part? Yeah.
The number of nodes that you have shown, because it is an example,
yes.
Only because there's a minimum number of nodes that are required for proper functioning and no takeover of a few from the others.
So there's no requirement for there to be many nodes in terms of preventing double spends, for example, or maintaining the blockchain. Everyone has their own node database and they can maintain that themselves. So there's no functional requirement for the node network to be busy or active. And in practice, because
there's an incentive concept, right, for the nodes in the notary, the notaries, so that they are actively acknowledging and doing their notary functions.
Okay, so you're saying how many nodes in the notary pool?
Yeah, that's exactly what I'm looking at.
So here, I mean,
that depends on the traffic. It depends on the traffic, how much activity is there. I know this is only a...
yeah, in theory. So we're working on making the notary faster. So we're working with Galera and Kafka. And in theory, Kafka, I think it can do 15,000 transactions a second. Then obviously it's constrained by the Byzantine fault-tolerant algorithms, which make it slower. But so a lot of our work in terms of performance recently has gone into making the notary pool fast enough to handle things from a lot of nodes. But you can have multiple notary pools.
So if you choose a consensus like DFT or RAP, right, then you have to have that number of nodes in the cluster of the notary.
That's true, yeah. So different amounts of nodes make sense for different algorithms, of course. So I think it would make sense to have a two-node DFT algorithm, for example.
You can partition the notary pool
For what purpose?
for improving throughput.
Well, I guess in Raft there's just a leader and then they divert all the consensus to the individuals. But the problem is if you want it to be DFT, often you need everyone to get involved. But for high speed,
No, but you can partition the space of all the transactions, and then you have separate notary server, notary pool for each partition.
Yeah, but that's effectively what Raft does something similar, where it just spreads it based on what you could. I mean, so you can write your own consensus algorithm, right? So if you find a good way to do consensus and people trust you, then you could join the network and become a service provider and offer this pool. Yeah.
I have a very basic question actually. Most of the blockchain platforms that I have worked on, basically they have a shared state of ledger that each peer actually seeks a peer. So every peer has a copy.
Yeah.
This is the first network where you are just keeping track of what that node is interested in and keeping track of that. I am not able to envision any problem as such with your approach, but isn't there any loss of data or integrity with that approach, or in terms of some nodes being malicious nodes? Is there enough research done in the space where is there any possibility that somebody can manipulate the state, because there is not all the nodes are in sync with the state, and there is no socially approved, based on the node, what is the current state. It's just that I know that I'm interacting with these two nodes and I have a state of only those things, and these guys will keep their own state. So what gives the validity to these transactions? Like how do I know which state is the valid state and which state is?
Yeah, so in practice you see, when we say need to know distribution of transactions and states, so you'll see the state and the kind of history of the state that makes it valid back to issuance.
This is only with 30 people. This is not.
There is nobody knows about it other than
the bilateral ledger, right? So only if we both are in.
But that's the problem. That's the problem that I'm trying to bring up. That if it's a bilateral ledger, there is no social acceptance of the transactions that are in there, because they are secreted, they are separated, and they are only agreed upon by those two, and only those two can see it. So how, if there is a dispute going to happen, how would I?
Because when they signed, there was a certificate proving that public key was associated with that identity, and they've signed that transaction saying, I owe you, £100, for example. Then you can take that to a court of law and you say, the person who was linked by this certificate authority to this IP address sent me over TLS encrypted channel a thing where they signed and said that they owed me this much.
And who guarantees the execution of? There are contracts have multiple participants interacting, and they have to hold up on their side of the contract, right? Who can make sure that a particular participant will abide by his side of the contract, and who forces him to do that, right?
Well, this might make more sense once we've looked at contracts and stuff. Can we come back to that?
Yes.
Yeah.
I just have a quick question.
Yeah.
So there's a notion of participants in the transaction, right? My understanding is that all the participants together with the transaction, even though the transaction body might be hashed, but the identities of all the participants needs to be encoded by the notary service, not just the sender of the transaction.
No, so because what happens is you just send the hash of the transaction notary, it marks it off and it sends it back to you, and then you do the data distribution to the participants.
But then how does the notary certify that those parties are involved in a particular transaction?
It doesn't need to. So again, this maybe will make more sense when we come back to this other day.
But I'm confused about the functionality of notary. What value does it provide?
So basically, if you think of the traditional Bitcoin problem where someone could spend money to one person and to another person, in Bitcoin it's impossible because everyone's got a record of the entire chain they can look. So in this case, the notary basically just has a list of transaction hashes and output indexes that it's already seen. So it says, you've already someone's already spent output 0 of transaction blah 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 blah, and then when someone spends that, they add it to their list, and they never allow someone to spend it again. And because the hashes are unique, no one can ever, some people still haven't found collisions in SHA-256 hashes, then the output index plus the hash uniquely identifies an output on the network, and you can only spend it once.
So the notary will have only the transaction hashes, not the data. So if two people want to share the data, then still the notary can have the data?
So yeah, you can set up a validating notary which checks the transaction's valid, so if you had a regulator or something, that might be a good idea. And so it's something we haven't implemented in the platform yet, hopefully by the end of the year, but we're moving towards also moving transaction validation to SGX enclaves, which is kind of a trusted computation environment where the notary couldn't see what they're validating. And at that point, we might switch all the notaries over to validating notaries because they wouldn't be able to see the contents of what they're validating.
Would there be a problem where the notary database will go fuse or something?
Yes, that's not so necessarily thought about for now. It's a design question on our mailing list. In theory, yes, so the notary might be doing 15,000 transactions a second, maybe in the future, 100,000, a million a second, so possible, probably. But at that point, but it's the same problem, I guess, banks have today, or big companies have today, where they've just got a growing data set. And in terms of, big companies using this to replace an existing business process, we wouldn't expect the cost of that to be prohibited at all. And the notary is a service that's paid for, so ultimately they just have to set a price or decide on a price that they're willing to accept to be a notary.
So who is notary in this case? Like, will it be a third party?
It depends on the network. So generally what we'd imagine is that service providers, third-party service providers, would bid perhaps to be a notary, and it would just be your standard, Cognizance and, I don't know, private service like Accentures, SAPs, I don't know. And they'd get together and they'd all join the same BFT notary pool. They'd be kind of sign, SLAs, service level agreements about providing this thing for going forward, and then they'd work together, but they'd mistrust each other to notarize transactions.
So today, without a validating notary service, how do you ensure the consensus of smart contracts running on different disciplines of the transaction?
So again, this will become clearer later, but generally what happens is anyone before signing the transaction will check that it's valid. So it's the individuals checking it, not the notary. In the same way as in, is there an analogy of Bitcoin here where you might refuse to sign a transaction if the coin's already been spent? I'm not sure. But it'll become clearer, I think, as we look through the model.
Okay.
So I have a question.
As a participant.
Sorry, what's the goal of the session? Are you going to present material, or is this a deep dive Q&A into some known topic?
So we're going to kind of work through the theory and build our own CorDapp. There's always a few questions. We can come back to some of these. No.
Just wanted to clarify.
Yeah. So no, we will be building a CorDapp. So let's just move on to get on some code. So the next thing we can look at are states, right, which are the shared facts represented on the ledger. And you can think of it as this. So we've talked about this a bit in our network view, but basically you can imagine 5 nodes here, Alice, Bob, Carl, Ed, Demi, and each of these nodes only sees certain facts. So Alice and Bob both see fact 1, and they're guaranteed by CorDapp they see the same version of fact 1. But only they have this stored in their database, only they see this information. So Bob, for example, isn't aware of 7 or 9 or 4 or 3 or 2 or 8. And then Demi will have their own set of facts, Carl will have his own set of facts. And this is because of the way data is distributed around the network, right? So Alice and Bob sign some legal agreement or some asset transfer, and this information is only distributed between these two guys over a encrypted channel. Then you also have 3-way agreements like this one here. So here Ed, Demi, and Carl have got together to agree fact number 3, but they're the only people on the network who know about this.
These states are getting the transactions. So these states depend, in some cases there are 3 states, some cases there are 2.
Yeah.
It depends on the level of transactions. Or
no, those are just numbers to differentiate them. You can have a transaction have as many inputs and outputs as you want. Yes?
The permissions that you refer to in numbers there,
Permissions?
are they changeable, modifiable?
So those aren't permissions, they're just facts. So they're just facts that people know. So Alice and Bob both have the same state instance stored in their databases as
That
well.
will be changing in time.
Yeah, so different information will get distributed to different people over time, yeah. There's no permissions really involved, it's just about sending to the counterparties who are involved in that transaction. And so if we want to look at, so we're going to just take a look at some code now. So the way the CorDapp state API works, so we've got these nodes on the network are represented as party objects, and states themselves are represented as contract state, kind of classes that implement the contract state interface. So I'm just going to pull up CorDapp now and just take a look through some code.
Yeah, well, I can't get on the network, so it's kind of useless.
Could I have my Chromebook? But I need a Java, right?
I'm running it on my workstation. But yes, you could use Cloud Shell.
I tried that with your thing. It didn't work.
So parties on the network are represented by this class here, this party class. So did everyone see that okay?
Yep.
So just bring that down a bit.
Is this in our project?
This is in the main CorDapp project, but you'll have this library included as a dependency. I think the ones on the USB keys only have the class definitions as opposed to the metadata, so you won't see the proper declaration. But if you clone and open up the CorDapp repository, you'll see this. So this is how we represent parties on the network. So as I said, everything in Java is kind of just an instance of everything in CorDapp is an instance of some Java class. So parties on the network are instances of the party class. We'll see that states on the ledger are instances of the contract state class. And so a party is just a pairing of a name to a public key. Okay, so it'd be like Alice and some public key, or some company name, some public key. You can see that party extends the abstract party interface, so in theory you could also be represented in a transaction as an anonymous party, which is just a party that's represented by public key only. So that's for privacy reasons, you might want to do that in certain cases. But for today we'll be just looking at parties. And so any party on the network is just a name plus a public key. Does that make sense? And so then we have the other thing we need to look at for now is this contract state interface. So contract state is an interface, and it's just any state on the ledger will have to implement this interface or one of its children. And anything that does that, any instance of a class that does that is considered to be a state, and that's what goes into transactions. And the only thing we have here, it has one field, which is participants field, and that's just a list of people that kind of have an interest in this state, the people that this state should be distributed to when you do a ledger update. Does that make sense? So you can look at throwing together a quick state now. So I'll just it's Kotlin, so I can just let me actually get some Java up. I might open the let me open the bootcamp CorDapp. I'm not sure if I messed around with this yesterday. I think I did. New window. So I'm just going to show you a quick example of defining a state. So I'll just grab a new one. Let me call it. What's something we could represent with a state? Anyone got any ideas? Just an example we can work on now. Anyone?
Sorry, what was that?
What's the question?
So what's an example of a state we could work on? I just want to define an example type of state.
Cache.
Token state here.
Yeah, so token state we won't do because we're about to do that for real. We could do cache.
Can you do a share, not cache?
Can we do what, sorry?
Some kind of a equity.
Yeah, we could do a share state, that's fine. So we've got our class here, and the first thing we need to do is this state needs to implement the contract state interface, right? And by doing that, that's effectively a state. And so then now if I do, let's say I was doing some kind of, I can do a public static void main in here, can I? Is that am I doing this right? I don't feel like I am. But yeah, I am. So here I could just, when I want to create a state, I could just say share state, my state equals share state. New share state. So I write Kotlin mainly. But so that's an example of how you create an instance of a state, right? It's just standard Java stuff. So we're not reinventing the wheel. We're just, in fact, CorDapp is almost providing just a library of interfaces as well as a node implementation, and you use these almost as marker interfaces to show that this is a state, or we'll see a transaction or a flow. Does that make sense? And then what we need to do is just, so if you remember there's one field in contract state, which is participants. So we just need to implement that here. and that's going to return null for now, and this is a valid state, right? You could stick this on the ledger if you wanted to. And so what's going to be the problem with this state? I mean, what?
Doesn't do anything.
We need participants.
Yeah. There's no participants and it doesn't do anything. So you've got two problems, right? So what we need to do is just put some information in this state. So what are some things that a share might have as properties?
Identifier.
Yeah, so it'll have some kind of identifier. Let's say that was a string. So we can say here a string identifier. And then here I'm just going to create a, I'll make it private and then it will pop up. I just want to create a getter for that. So that would have been generated. I should put that. And also I probably want to add that to the constructor. How do I do that? Script. There we go. So now I've created a constructor. So now we have one thing in our share state, right? So when we create an instance of this share state, we'll add an identifier to it, and then it'll start to actually represent information on the ledger. Is there anything else you could put in there? I mean, any other?
Owner.
Sorry?
Owner.
Yeah, the owner, exactly. So here we can also put in the owner, so that'll be of type party. And then we probably want to add that to the constructor. So we can do that. We can provide a getter. And we probably want to update get participants to return a list of, so I'm just going to use Guava here, but a list of the owner. So those will be the participants. So this is the person who hears about updates to this state.
One question actually.
Yeah, sure.
What is owner actually? Owner is what is the concept of owning the state? What does that mean?
Well, in this case, it's just we've defined that field. But in this, it doesn't really, we've just defined that, right? There's no concept attached to that. It's just that this is, the owner is one of the participants. So if there's an update to this state, they'll hear about it. So I could also, we could call it anything else. We could call it, holder or something.
That's the owner of the share.
Yeah, but only because we're defining it that way, right? We're not using any primitives of CorDapp here. We're just defining fields in our state. And anything else we can put in there? I mean, well, so that would be more in the transaction level. So the state is just a snapshot in time, right? So you wouldn't represent a deal as a state. You represent an asset as a state or an agreement as a state.
Oh, okay.
But you might, I don't know, you could also put up, let's say,
Purchase price.
purchase price, maybe, yeah. Private.
Maybe the stock exchange.
Yeah, so we can just, so you can just kind of keep adding stuff. So I'll stick this in, and I'll stick, I'll stick in a getter. There we go. So, and then, and this I'll stick.
Date of purchase might be a property of transaction or share, or stake.
It depends, yeah. So if you put issue date there, or you could look back and look at the transaction to work out when it was issued. So it's completely flexible, right? It's up to you to work back from a business case you have to work out what's a valid way of representing a share on the ledger. And the other thing we could do perhaps is just add one more, which would be the issuer, let's say. So we get a constructor field. We could add a getter for this. And importantly now we've got a choice, right? We can either make the issuer one of the participants and they'll hear about this share state moving around the ledger, or we can leave them out of the participants and they won't hear about it. And that's kind of up to you, right? That's a business decision that you have to make based on your use case of who you want to see this information, whether it's a legal requirement perhaps for the issuer to be kept in the loop as updates happen, or whether it's not. Okay?
Could you also put some conditions? Like this thing happens only if...
That's what you put in the smart contracts. We'll look at next. Does this make sense? So we're going to start building our own state now. So yeah, Mark.
So if I'm looking at this from a viewing standpoint, effectively what this is taking all properties that have estates from the top of the contract, and that's taking like just the top of the contract all over time.
Yeah, so it's CorDapp uses a UTXO model. So if you think of if we go back to Bitcoin, in Bitcoin you have those Bitcoin states that represent a current value of Bitcoin held by someone. And then the platform has built-in rules about how that can evolve over time. So it's very different from Ethereum. There's no stateful objects on the platform. It's just a series of states that replace each other over time. Okay? Yeah, sorry, go ahead.
The CorDapp system will call that get participants call to figure out, how it's supposed to distribute the state.
Yeah, so once we look at flows, you'll see how that works. There's a flow you call at the end, there's like a sub-flow you call at the end of flow called financial flow, which is saying notarized and distributes it as required.
So basically, you're required to define that so that the system can do its job.
Yeah, exactly. So you know who should store it. Yeah. And your question, sorry?
Sure. So you said that it's basically a series of state replacement.
Mm-hmm.
So is there a notion of some kind of state ID that you basically use a new value to replace an old value?
Yeah, so in practice, we won't look at it today, you could choose to implement linear state, which is a subclass, it's a sub-interface of contract state. So if I look at linear state here. Oh, I'll bring it up in quarters, sorry. So linear state is exactly for that purpose. So here, it extends the contract state interface to provide the linear ID. And so if you want to provide, model some deal that evolves over time or some asset that's tracked over time, you might implement this interface and the linear ID will be shared over that history and you can reconstitute the history.
So without doing this linear state, the intention would be that state is essentially immutable. Once it's written to the ledger, then it's
so we'll see when we look at transactions, what will happen in practice is even if it's not a linear state, you'll go and consume this existing contract state, this token state, to produce a new token state based on the contract rules. So we can jump into the coding now. I'm about to die. But so what we want to build now is our token state, right? So it's going to be very simple. So it's going to be a class that implements the contract state interface. It will have these properties for the relevant getters and constructor stuff. And it will have these participants, the issuer and the recipient. Okay?
Do you need juice?
I'll grab some in a sec. Hopefully it'll last long enough. So this is basically what we need to do now, right? So we're going to, if you open up your Bootcamp CorDapp and let me know if it's having trouble, just open it up, and basically what we want to do is we've got some tests defined under state tests, and what we need you guys to do is to modify the definition of token state so it actually implements that interface we just talked about and all the tests pass. Does that make sense? So I actually kind of need this on the same slide as the last one. So me and Case will be wandering around, so let us know if there's anything you don't understand, if you have any questions.
What did you say? It was Android AP. Is there a password?
Yeah.
Do you want to put it in?
Question. Has these notary features in CorDapp been used in LCs, SBLCs, and bank guarantees? There are a few
Thank you.
bank institutions.
Don't leave.
My phone should
LC is, electron credit, and then SBLC standby electron credit. Bank guarantee, there are similar concepts. Are they also used to be stored and in your?
Yeah, so we don't have anything quite in production yet.
Oh, okay, good. You have listed.
So we have good stuff in production for gold trading, securities lending, reinsurance. There's a big project called Marco Polo, which is
I swapped out my corporate account when I was leaving them, and now I've got 5 gigs a month, and I keep getting warnings like 10 days into the month.
Yeah, you watch that one YouTube.
Any modification?
It's weird because I used to be completely indifferent to it.
Yeah.
Any different?
Treat it as infinite. Now I'm like anal about it.